Take a moment and think about the biggest decision you ever made. The job you didn't take, the person you didn't marry, the moment you turned left when you could have turned right. What if every one of those choices, every tiny inflection point in your history, wasn't a choice at all? What if you made all of them? Not hypothetically, but simultaneously. This is the unnerving heart of the Multiverse Paradox. It posits that somewhere, in an almost unimaginable expanse of reality, an infinite number of copies of you exist. One of them is a billionaire, another an astronaut. One made the wrong turn and never came back. And perhaps the most unsettling thought of all, if they are infinite and space is vast enough, one of them is the exact perfect mirror of you, right now, experiencing this exact moment. This idea shatters our perception of free will. It opens up the regret engine. Imagine the small but pivotal choices, the investment you pulled out of just before it skyrocketed, the courage you lacked to speak to someone who could have been the love of your life, the last words you didn't say. In one parallel life, you stayed on that losing investment, only to see it rebound into a fortune. That version of you is rich, traveling the world, living a life of absolute financial freedom. In another branch, you spoke up. You are happily married to that stranger, building a family in a city you've never visited. And in the most painful branch, you were present. You said what needed to be said, and that burden of regret was never yours to carry. These alternate versions of you are not dreams. They are not fantasies. According to the deepest mathematical models we have for describing reality, they are equally real, equally existent. They are simply operating in a separate, non-communicative branch of existence. The multiverse is more than a fringe concept born from science fiction. It is a mathematical necessity that springs directly from our most successful theories in cosmology and quantum physics. It is a revolution in how we define reality, existence, and the very concept of self. For the next 3,000 words, we will dive into the 4 levels of reality proposed by physicist Max Tegmark. We will explore the chilling implications of parallel selves, investigate the theoretical limits of interaction, and look for the literal bruises of other universes in our night sky. This is the ultimate cosmic deep dive. Let's begin by defining the infinite. The easiest way to grasp the multiverse is to start with the simplest definition, one that requires almost no radical new physics. This is Tegmark's Level 1 multiverse, the infinite patchwork. The core assumption is simple. Our universe is likely infinite in spatial extent, or at least so vast that its boundaries are irrelevant. The second assumption, the distribution of matter and energy across this infinite space must eventually repeat itself. Consider a Rubik's Cube. There are over 43 quintillion ways to scramble it, a massive number, but finite. If you had an infinite number of Rubik's Cubes, eventually every single configuration would repeat. The universe is similar. The particles, the atoms, the stars, galaxies, they are all finite configurations of matter. Though the number of possible particle arrangements within a sphere, the size of our observable universe, is staggeringly large, a 1 followed by 10 to the 115 zeros, to be precise. If the overall space is infinite, those configurations must repeat. Therefore, somewhere, unimaginably far away, there must be another planet Earth, another you, another me. The math suggests that your closest identical twin, the person who has lived your life exactly up to this very second, is located about 10 to the 115 meters away. That number is so large, its physical distance is impossible to visualize. The distance is immense, but the concept is profound. Your double is a geometric certainty, not a magical possibility. This Level 1 multiverse is a simple, if mind-bending extension of the universe we already know. But our second level, Level 2, breaks free from our universe's laws entirely. The bubble universes and the cyclical cosmos. This concept is rooted in the most successful yet least understood aspect of the Big Bang theory: cosmic inflation. In the first fraction of a second, the universe expanded faster than the speed of light, a phenomenon that smoothed out reality and seeded the structure we see today. But what if this inflation never truly ended? What if it is eternal chaotic inflation? Imagine our universe as a small bubble forming within an eternally boiling cosmic foam. Russian-American physicist Andrei Linde proposed that the creation of universes is an ongoing fractal process. Regions of the larger inflationary space constantly bubble off, each bubble marking the moment inflation stops locally, creating a new Big Bang. Our universe is one such bubble. The crucial difference here is that since these bubbles form independently, they can have different physical constants than ours. One bubble might have a stronger gravitational force, preventing stars from ever igniting. Another might only have 2 dimensions of space. The laws of physics are not universal. They are local to the bubble. This also ties directly to the concept of a cyclical multiverse, an ancient philosophical idea now modernized by theories like loop quantum cosmology and the Big Bounce. Instead of a single beginning, the Big Bang, the Big Bounce model suggests that when our current universe slows down and eventually collapses in a big crunch, it won't disappear. Instead, the incredible density of the collapse will cause it to bounce back out, igniting a new Big Bang and starting a new universe. In this scenario, our universe is just one cycle in an infinite chain of creation and destruction. The before moment is simply another universe, and the after moment is the next. We are part of an infinite cosmic time loop. This adds a profound time-based element to the Level 2 multiverse. Our reality is not only surrounded by other bubble universes in space, but is also preceded and followed by them in time. If Level 1 is about infinite distance, and Level 2 is about infinite physical laws, Level 3 brings the multiverse right into your mind, existing not far away, but right here. This is perhaps the most shocking and literal interpretation of parallel selves. Hugh Everett's Many Worlds interpretation, MWI. To understand MWI, we must confront the biggest mystery in quantum physics, the problem of measurement. Quantum mechanics dictates that subatomic particles exist in a state of superposition, a blurry combination of all possible states at once. The famous example is Schrödinger's cat. Until the box is opened and the quantum state is measured, the cat is simultaneously both alive and dead. When an observer measures the particle, the wave function collapses and only one outcome is observed. But why does the wave function collapse? In 1957, physicist Hugh Everett III proposed a radical, elegant, and deeply unsettling answer. The wave function never collapses. Instead, every time a quantum event is measured,
Every time a decision is made, the universe splits. In one branch, the electron spins clockwise. In another, it spins counterclockwise. In one branch, Schrödinger's cat is found alive. In a parallel, equally real branch, the cat is dead. And critically, in one branch, you decided to read this far. In the parallel branch, the copy of you clicked away minutes ago. This level 3 multiverse is not separated by distant space or changing constants. It is separated by every single quantum interaction that has ever occurred. The branches are continuously created, minute by minute, second by second. This is the most literal home of your parallel self. You are not geometrically required to exist far away. You are mathematically forced to exist in every single branch created by every choice and chance event since the Big Bang. It's a terrifying democracy of chance. Every failure in your life is a success for another version of you. Every regret you hold is a triumph for a parallel self. And since these splits are quantum, they are happening millions of times every second, creating a tapestry of infinite, slightly different yous existing just beyond our perception.
If this parallel self is so real, why can't we communicate? Why don't we see the universe is splitting? The answer lies in decoherence, the firewall between realities. Decoherence is what makes the quantum world become the classical world we experience. When a quantum system, like an electron, interacts with its environment, like a photon or an atom, the delicate superposition state is instantly destroyed. In the many worlds interpretation, when a universe splits, the two resulting branches immediately decohere from one another. They become fundamentally non-communicative. They are, for all practical purposes, separate realities. The matter and energy that form your body are perfectly entangled within your branch, making you irrevocably linked to this reality. You cannot see the light from the parallel branch. You cannot feel the heat from the parallel branch. This acts as a seemingly impenetrable barrier. Your parallel self is physically near, but observationally unreachable. But human curiosity demands that we search for theoretical loopholes. Could there be a way to bridge the gap? One speculative area lies in extreme gravity, black holes. Since general relativity and quantum mechanics break down at the singularity, some theories hypothesize that the bizarre conditions inside a black hole could potentially act as a nexus point, a place where the membrane between level 1 or level 3 realities is stretched thin, allowing information or even matter to pass through. Though purely theoretical, the black hole represents the ultimate breakdown of our known physics, and thus the most likely place for a breach. Another, more subtle possibility relates to dark matter. Dark matter makes up 27% of the universe, and we know it only by its gravitational effect. We cannot see it, and it does not interact with light. What if dark matter isn't an exotic particle in our universe, but the gravitational signature of matter in a parallel universe? This is the hidden mass hypothesis. If a parallel universe existed slightly offset from ours, its matter might interact with our matter only through the weakest force, gravity. The 27% missing mass we call dark matter could in fact be the shadow of a parallel reality. If this were true, it would mean we are constantly being influenced by a parallel universe. A large, dense parallel cluster could be affecting the rotation of galaxies in our reality without us ever seeing the source. The influence would be constant, invisible, and universal. We would literally be tethered to a neighboring reality by the very fabric of space-time. We now move to the most expansive and abstract concept of them all, Tegmark's Level 4 multiverse, the mathematical universe. This is a radical leap. Tegmark argues that if all possible universes described by slightly different physical laws, level 2, exist, then perhaps all mathematically possible structures exist. If a universe can be perfectly described by mathematics, and all our physics suggests this is the case, then every mathematically consistent reality must exist. This means that reality is not defined by what is physical, but by what is logically possible. If this level 4 multiverse is true, then level 1, 2, and 3 are simply subsets, small patches within an infinite, all-encompassing mathematical ensemble. It's a reality where physics is not a discovery, but a description. We are not finding the laws of the universe. We are simply recognizing the specific mathematical structure that our consciousness happens to inhabit. So, how do we search for evidence of these structures? How do we find the scars left by other realities? One key area of research is the cosmic microwave background. The CMB is the afterglow of the Big Bang, the oldest light we can observe. It is a nearly uniform hiss of thermal radiation across the entire sky. If our universe bubble, level 2, collided with another bubble in the past, that massive violent impact could have left a bruise on the CMB, a subtle, non-random temperature anomaly, perhaps a ring or a cold spot. Scientists have searched for these signatures, and while some anomalies have been found, like the unexplained CMB cold spot, they remain highly contested and have not yet provided definitive proof of a bubble collision. Another line of evidence comes from the possibility of a big bounce universe. If our universe was indeed born from the collapse of a previous one, there might be relict gravitational waves or subtle distortions in the CMB that carry the imprint of the pre-bounce cosmos. Researchers are hunting for these fossil imprints of the universe that came before ours, looking for the quantum signatures of a previous cosmic cycle that persisted through the immense pressures of the bounce. Finally, we consider the Fermi Paradox, the glaring contradiction between the high probability of extraterrestrial life and the universal silence. Where is everybody? If the multiverse is real, the paradox may be solved. If life requires a precise set of physical constants, specific values for gravity, electromagnetism, and the speed of light, then the universe is an example of the anthropic principle. We exist in one of the incredibly rare level 2 bubble universes where the laws of physics are perfectly tuned for life. The other bubbles are either too short-lived, too cold, or have physical laws that prevent matter from ever forming complex structures. In other words, they do exist, but they are physically unreachable because their reality is governed by a completely different set of rules. The multiverse forces us to confront an unnerving truth. Reality is likely much, much larger than the tiny cosmic fraction we inhabit. From the geometric certainty of the level 1 infinite expanse, to the chronological cycles of the Big Bounce, to the radical splits of the many worlds interpretation, the possibility of other realities is not a philosophical luxury. It is the direct consequence of the mathematics that successfully describes our own existence. And if these theories are true, then the very concept of your identity dissolves into a vast branching sea of selves. Every moment of indecision, every path not taken, every lost opportunity is simultaneously being lived out by a copy of you. You are a single stream in an infinite river. Will we ever find definitive proof? Perhaps.
The ongoing search for CMB anomalies, the hunt for big bounce signatures, and the deep research into quantum entanglement are all probing the edges of our known reality. But for now, the ultimate consequence of the multiverse remains a chilling question, not a confirmed fact. You have no idea how vast the universe is. You have even less of an idea how vast you are. And somewhere, right now, a parallel you is looking out into the same night sky, thinking the exact same thought, in a reality that branched away from yours just milliseconds ago. Thank you for joining us on this deep dive into the multiverse paradox.